Hi guys, I'm Kwan Nguyen, aka Josh. My project is a development of an environment in science explorer for Birmingham. This project is guided by Dr. Adele Aneba. As the world is getting ready to begin the second decade of the 21st century, it's been recognized that the global climate change is a real threat to the current civilization. The economic growth of developing nations is significantly contributing to climate change. Managing air pollution is a key for human well-being, as air pollution shares with all other threats to public health and welfare. The higher awareness of the air pollution of citizens will lead to a better public health. Birmingham is a city with about 2,600,000 citizens in 2020. As an urban place in the UK, is facing with various environmental problems such as emissions from traffic, factories, heating, cooking, and refuse burning. Particularly, NO2 and O3 are the key pollutants that pose a significant challenge to improve the air quality in Birmingham. Birmingham City Council takes its environmental responsibilities seriously into a project to work to ensure Birmingham is a great, clean and green city. There are many different approaches to monitoring and analyze air quality, but many of them are based on historical data and the environment data of local stations. So data records may be different from real-time situations. There's lack of view on the importance of data visualization and a lack of view of visualizing the forecasted results for users. Finally, the lack of unifying of many captured data sets from different sources such as air quality, city traffic, weather. So an urban data platform is needed to bring all these data sets into one platform. This project aims to build an innovative and smart online tool, manage air quality data using cutting-edge technology. This tool will be used to monitor and analyze the status of different elements such as CO2, NO2, temperature, humidity, PM2.5, PM10 in a particular area in Birmingham City. Objectives of this project are review the latest emerging technologies and research around smart city service development in the Web of Things paradigm using primary and secondary research techniques. Define the requirements for the intelligent environmental air quality system at the front and back ends. Design a prototype for an online air quality system using appropriate design method. Develop a prototype for the proposed system using a state-of-the-art development framework. Evaluate the developed system using an experimental approach. Document the findings and the outcomes. Many methodologies were considered for this project. These included waterfall, rapid application development, and agile. From comparing the methodologies, the agile method is preferred as it is the best suited for this development. Agile methodology is a circular and progressive approach to evolution, developing timely, cost-efficient, and high-quality solutions. As illustrated in the picture here, agile methodology consists of 6 steps: plan, design, develop, test, release, and feedback. In particular, the agile methodology Kanban will be used. This helps visualize tasks and limit the current work in progress to maximize efficiency. The proposed system is divided into 5 layers: data fusion, network, storage and management, data processing, and data visualization. An ETL framework is also built on top of this architecture. In the extract phase, data from various sources is extracted. At this stage, Python is planned to use to create data retrieve module that automatically retrieve real-time data from providers, and also air quality data from monitoring sensors are measured. Because data from providers and raw data from sensors are in different formats, Python is used to get them uniformly represented in JSON and stored in the database for subsequent processing. In the transform phase, the data will go through a series of rules and functions to transform the collected data into a format for data presentation. Because the extract information is not fully used, but the additional data will facilitate with visualization performance. Apache Spark is used as an analytic engine to clean, filter, and reassemble the unneeded parts of data. Then data are fetched into tables depending on what type of data they are. The load stage loads the transformed data into a visualization page. This module is a link between the visualization pages and the data storage framework using RESTful web services, and visualized data will be displayed on a web portal. This project contains these feature technologies: ETL framework, Node-RED framework, MQTT protocol, Apache Spark, MySQL database, and Python Flask API. ETL is a technique for extracting and converting data from the web into a visualization system. ETL consists of 3 parts: extracting, transforming, loading. The functionality of each element has been discussed in the previous slide. Node-RED is a visual tool for writing the IoT developed by IBM Emerging Technology and the open source community. Using Node-RED, developers wire up input, output, and processing nodes to create flows to process data, control things, and send alerts. MQTT protocol is an open OSIS and ISO standard. It is a lightweight publish subscribe network protocol that transports messages between devices. MQTT has low network overhead and can be implemented on low power devices such as microcontrollers that might be used in remote Internet of Things sensors. Apache Spark is an open source clustering framework. It is a distributed system architecture that processes massive amount of data and used in conjunction with other components to collect, store, and calculate data. Apache Spark has rapidly grown into the preferred big data analytics solution for unstructured data. MySQL database is a low-memory CPU and the world's most popular open source database. In this project, data is stored in a local and cloud MySQL database using both Node-RED framework and MQTT protocol. Flask is a lightweight web application framework. It's designed to make getting started quick and easy with the ability to scale up to complex applications. Flask is used in this project for the role of data transfer and encapsulation. Flask provides tools, libraries, and technologies that are used for the web application. I'm now very excited to show you guys the result that I got. For the data ingestion, data is being retrieved from two sources, the monitoring system and the agent API. The pictures here show the data provided from the monitoring system and the data capture on the serial monitor. By using Apache Spark, the daily and weekly average of PM2.5, PM10, NO2, O3, temperature and humidity is reliably and consistently calculated and saved in a separate table in the database. This figure here shows the calculated average data saved in the database. So after retrieving data from waqi.info, data is being cleaned, filtered, and formatted using Python before storing into MySQL database. And data of different elements are also saved in different tables from the monitoring system using Node-RED framework. The Urban Data Platform provides a simple and concise user interface which displays the live air quality data for Birmingham. And the platform also provides live charts of temperature, humidity, O3, PM10, PM2.5, and O2. So the users are able to see the changes in these elements within a short period of time. It provides user with the ability to recognize new patterns and errors in the data. For example, if the live data fluctuates, this gives an indication that there's some change in one of the environmental sensors. A chart is implemented for the data in the past 7 days. The average is taken for each of the elements, and the data is translated into visual context in a graph design. This brings deeper insights for decision makers to analyze and act upon the results shown. On the right panel of the platform, a widget is placed to provide user a visual look to understand the data more efficiently. PM2.5, PM10, and O3 formulate the air quality for Birmingham. The air quality scale is emphasized by the large text and the colors, which is used to represent green for good, yellow for moderate, and red for unhealthy. A map is also provided at the bottom of the web interface. The primary purpose of incorporating this simplifies user navigation, offering an efficient method of locating data for a specific geographic region. So to sum up with what features this project has implemented are a semantic ETL framework for air quality detection and visualization, RESTful web service as an API to provide intuitive knowledge field, a web interface to get the data from a predefined API to show the monitor results using live charts and leaflet map APIs, air quality data analytics. However, this project could be improved by implementing deep learning and machine learning, LoRaWAN, high performance machine, more data set, and more locations. Thank you for listening.